Good morning, good afternoon. Thank you for joining this webinar by Bureau Veritas that will be dedicated to the topic of sustainable marine fuels services and especially the de-risking of the full chain. Maybe before to start, we will remind a few rules. Next slide, thank you. So all the microphones have been muted for all participants. If you want to ask any question, please use the Q&A section. The comments are disabled, and we will try to answer your questions at the end. All the questions that cannot be answered during the webinar will be answered afterwards. Important as well is that this webinar is recorded, and you will also receive the recording after the session. So now I will present you the speakers. So starting with myself, so my name is Laurence Boiramé. I am the Global Director in charge of hydrogen and derivatives, as well as carbon capture, use and storage for Bureau Veritas Group, part of the industry product line. Today, I will be joined with colleagues from industry and from Maritime Department of Bureau Veritas. So Nicolas de Gors, who is a sustainability project lead within Bureau Veritas Marine Department, as well as Victor Robin, project manager in decarbonization in our industry department, and Julien Boulan, sustainability strategy leader in our maritime department. So just to introduce a little bit who we are. So Bureau Veritas is a very old company. In 2 years, we will celebrate our 200 years anniversary, and we have been active in the maritime industry since then. We are also active in the energy and industry sector since more than 100 years. We tend to say that we are a business to society. What it means that our clients are mainly businesses, enterprise companies, as well as governments. But what we are doing, spanning from quality, health and safety, environmental protection, and social responsibility, is for the benefit of the overall society. And the way we do this is to provide technical advisory, owners, engineers, testing, inspection, certification, and a bunch of technical services. And this is exactly what we will present you today. Next, please. So here you can see on the bottom of the slide that we are active in very different sectors across maritime and offshore industry, agriculture, food, commodities, industry, including energy production and infrastructures, buildings, consumer products, and we are also delivering certification in all of these sectors. Today, we are, I would say, talking about topics spanning renewables and low carbon assets, so where the low carbon energy, low carbon fuels will be produced, being from electricity converted in hydrogen, so the power to X, such as ammonia, e-methanol, e-methane, for instance. And we are also, I would say, using our expertise in green and low emission ships. So that's where, with our maritime department, we help in the progress of the new ships that will be with alternative powertrains and more efficient. We are also using our sustainable fuels capabilities, and especially the testing and the measurement of the molecules themselves, such as biomethane, bio-LNG, and e-molecules. So with this, I will hand over to my colleague Julien, who will introduce the challenge for the maritime industry.
Okay, thank you very much, Laurence. So after this introduction of Bureau Veritas, I will move to the context of sustainability and greenhouse gas reduction in shipping. So every day, ships carry 80% of the world's goods across the oceans, and this vital sector accounts for around 3 to 4% in terms of human-generated CO2 emissions. So the pressure to change is mounting from multiple directions, as you can see on the slide. So regulators like the EU, the IMO are implementing mandates for cleaner shipping, as you know. On the other hand, consumers and investors are demanding sustainable supply chain and ESG commitments. And on the other hand, rising fuel and carbon prices are making decarbonization not just an environmental imperative, but also an economic one, which is good. So here's the opportunity. The technologies are here or are emerging, and the real challenge is not about capability, but it's about implementation at scale and organizational commitment. So the maritime sector energy transition represents both an environmental responsibility and also a competitive advantage, we believe. And the question is not whether decarbonization will occur, but how quickly we can adapt. So the next slide, please. So now I would like to move on to the topic of the webinar today and how Bureau Veritas is able to support on this topic of sustainable marine fuel. So as we move towards sustainable marine fuel that are coming, 4 critical challenges demand our attention. So first, inconsistent regulation across the EU, the IMO, and national jurisdiction create a complex compliance landscape. And this is one of our duty, I would say, at Bureau Veritas to help our clients on that. Second, limited feedstock availability and high cost drive significant price volatility. Third, we face a financing dilemma. Producer needs offtake contract to secure the funding on one hand, while ship owner need insurance coverage for unproven technologies. And finally, mandatory traceability requirement under the RED 3 and IMO LCA guidelines add operational complexity. So these challenges, they are interconnected, but they are not unsurmountable. And that is the purpose of our webinar today, to share with you how Bureau Veritas will help you on those aspects. Now I'm happy to pass the floor to my colleague Nicolas, who will drive you through our offer. Thank you very much.
Thank you, Julien, and thank you for joining. Good morning or good afternoon to all of you. I will start with maritime regulatory context, which sets the base of most of the maritime decarbonization effort. Even if it is one of the most efficient transport modes, shipping must decarbonize, as it is the main transport mode, as Julien just explained. Shipping is currently emitting about 1 gigaton of CO2 equivalent, meaning around 3% of all fossil GHG emission. And to decarbonize, IMO has adopted a decarbonization trajectory in 2023 with a target to reduce by at least 20% its emission by 2030 compared to 2008 and by 70% in 2040. Similarly, EU has defined a decarbonization trajectory for its economy. This has led to multiple regulations to support the use of sustainable fuels in shipping. Today, we have 2 main groups of regulation, one developed by EU and the other one being developed by IMO. In order to be delivered to a vessel, a sustainable fuel has to be certified as sustainable. This happens thanks to sustainability frameworks. EU has the Renewable Energy Directive, the RED, and a set of certification schemes recognized by the EU. IMO has the LCA guidelines, which are not complete yet, and therefore no certification schemes is approved by the IMO yet neither. This should happen in the next couple of years, hopefully. Once the fuel is delivered to the vessel and used on board, it is reported through EU MRV or IMO DCS to be used in incentive regulations such as FuelEU Maritime and the ETS for the EU, or the IMO Net Zero Framework and the CII for the IMO. EU has 2 incentive regulations for shipping, ETS and FuelEU. They both use the same geographical scope, 50% of the voyage from outside EU to EU or from EU to outside EU, and 100% of all emission inside EU ports and between EU ports. The ETS, Emission Trading System, was extended to shipping in 2024 with a progressive entry into force, which finished last year. The principle is rather simple for shipping. Each ton of CO2 equivalent emitted in the EU scope corresponds to one EUA, one European Union allowance, which can be bought on a market. The scope is tank to wake, but biofuels are considered zero CO2 emissions. FuelEU started in 2025. It sets a limit of GHG intensity of the energy used on board. The limit decreases every 5 years, and a flexibility mechanism exists allowing vessels to trade under and over compliance. If a vessel remains under compliance at the end of the trading phase, it has to pay a penalty, which is much more expensive than the sustainable fuel premium, leading to a fuel change. IMO, on its side, is designing a regulation which is similar to FuelEU, and it tends to limit the GHG intensity of the energy used on board. It is a two-tier mechanism with two GHG intensity limits, the direct compliance target and the base target. If above both of them in the red area, the vessel has a tier 1 and a tier 2 deficit. The tier 2 deficit can be compensated with surplus unit from another vessel or by buying tier 2 remedial units. If it is in the yellow area, it will have to pay for tier 1 remedial unit. And if it is in the green area, it will generate surplus unit. If a fuel is below 19 grams of CO2 equivalent per megajoules, it will be considered a zero or near zero technology called ZNZ, and it will have access to a reward yet to be defined. IMO has approved the net zero framework in spring 2025. At least 6 months after, the text can be adopted. This was expected to happen in October 2025. However, following strong pressure from some countries led by US, the adoption was postponed to another extraordinary MEPC expected for October this year. But to be transparent, optimism has decreased on the potential adoption of this measure. Yet the discussion during MEPC 84 in a couple of months will provide some insight on the future adoption. If it is adopted, it will most likely be enforced in March 2028 with the first year of data collection in 2029. Given the uncertainty of IMO measure, many countries are developing their own measure following EU example. UK, for example, following post-Brexit agreement with EU, is developing a measure which will mirror the EU ETS for shipping. Turkey has adopted all the regulatory mechanism needed to enforce an ETS for shipping, but has not done it yet. Similarly, China is testing an ETS in Shanghai for national shipping. Some African countries have adopted an African sovereign registry system. We could also talk about Brazil work on a monitoring system, and so on and so forth. All these regulations are relying on their own monitoring method and their own sustainable fuel certification method, which will lead to a very complex and time-consuming regulatory patchwork. Talking about fuel certification, now that we have been around shipping regulatory context, let's have a look to fuel sustainability framework with my colleague, Victor.
Thank you, Nicolas. So hello, everyone. I'm going to talk a bit more about the sustainability frameworks for marine fuels. And especially, we have to tell that across the world, in many regions, we see that many policies have been launched towards sustainability to reduce the carbon intensity of fuels. Today, we will focus mainly on what we present today, so EU framework and also the international framework through the IMO. So basically, in Europe, the most important text that defines the framework for alternative fuels, so it can be biofuels or e-fuels, is the Renewable Energy Directive. It was published, the first version in early 2011, but the most important one is RED II that was published in 2018. In this text, there was the definition of sustainable fuels, of biofuels, of biomass fuels, of many sustainable products that have been reused in all the other texts. For instance, FuelEU Maritime, which is the text, the European text that frame the objective for the marine sector, also use the same definitions for sustainable fuels. And same thing for the EU ETS, the emission trade system, that can provide reduction with the use of sustainable fuels. And the definition is also the same as in RED II. So basically, RED II defines for every sector, not only the marine sector, but in every sector of the industry in Europe, objective to reduce the GHG intensity of the fuel consumed. And so the marine sector is one of them. And we see, like on the left part of the slide, an extract from FuelEU Maritime that defines this objective. So basically, when we look at RED III, which is the update of RED II that was published in 2023, it sets binding targets for 2030 for transport sector. And it consists of two different possibilities, either 29% of renewable energy in the final conception, or 14.5% of GHG intensity reduction compared to 1990. And so through this text that includes shipping in the transport targets are defined the different criteria, the different process to qualify a fuel as sustainable or as biofuel, e-fuel, etc. And that allow the fuel to be used to reach this target. And so, for instance, on the right side, on this Article 4 of FuelEU Maritime, we see several objectives of GHG reduction, January 2025, 2030, etc. And the way to use to reach this objective is, for instance, to use the biofuel certified through the RED II criteria. So what are these criteria a bit more, and what are the categories of fuels? So basically, we think, thanks to RED II and RED III, we see different categories of fuel. So first, the biofuels, or bioliquids and biomass fuels, are fuels that are used biomass or bioenergy. So the origin of the energy is from bio. However, it's not the only type of fuel. There is also the RFNBOs, the renewable fuels of non-biological origin. These fuels, also called e-fuels, are made from electrolysis and from renewable electricity. We also see recycled carbon fuels that can be used from recycled plastic waste, for instance. And so we are about to see also a new scheme for low carbon fuels. So a delegated act has been published recently on low carbon fuels. Low carbon fuels is kind of similar to the other fuels like RFNBOs, but it's mainly focused on the carbon intensity. So once the regulations have defined this criteria, we have to see some certification schemes to qualify the fuels. So that's the rule, for instance, of IACC, Certify, 2BS, which are examples of certification scheme to make you able to qualify your fuels as sustainable and compliant with this text. So there are many criteria to fulfill. There are the sustainability requirements on feedstock, on the nature of your waste, of the renewable aspect of your electricity. There is also a GHG emissions threshold. So a maximum for the whole life cycle of your fuel. It depends on your type of fuel. For instance, the formula to calculate the carbon intensity is written down left on the slide. So it's slightly different between biofuels and RFNBO and RCF, but basically they are quite similar. So the total emissions are, for instance, for RFNBO, the sum of the emissions of inputs, emissions of process, emissions of transport and distribution, emissions of use, and you can claim a credit for carbon capture and storage. That's an example. You also have some other criteria to ensure the traceability through the complete supply chain, that the quantities are well measured, that the sustainable aspects are not lost, that there is no double counting, for instance. So there is the mass balance criteria, the traceability and chain of custody criteria, and the management system that has the objective to ensure that every fuel producer has all the internal procedures and assets and team to qualify the fuels and to validate the different criteria. So as an example, in this chart, bottom right on the slide, this is an example of calculation that can be done on a sustainable fuel production. So through all the life cycle of the fuel, we calculate the emissions in gram CO2 equivalent per megajoule. So in order to have one single threshold for all of the fuels, we stick to megajoule. And as the threshold of RFNBO and RCF is at 28.2, with the fuel at 12.5, I am compliant. So that's an example of the criteria. But if we go outside EU and more on the international framework, in the international framework, we have to go to the IMO, the International Maritime Organization, with the adoption, of course, of the Net Zero framework. And to kind of follow what EU did with the FuelEU Maritime and the RED, the IMO launched the LCA guidelines, which are a methodology to define life cycle GHG intensity dedicated especially for marine fuels. So as Nicolas said, it's ongoing. A first version was adopted, but it's not entirely finished. And basically, when we look into these guidelines, we see that it's like many different equations, precisions to calculate the carbon intensity, and we kind of see a similar equation as per RED 2. So you can see the sum of the GHG emissions in well-to-tank approach will be sum of emissions from feedstock, cultivation, extraction, use, etc., land use change, process, transport, distribution, etc. We find the same terms as in RED 2. So even though the methodology is slightly different, once you have understood one, it's easy to understand the other one. And our role, Bureau Veritas, in these LCA guidelines, as one of the actors of the sector, is to help the IMO define the LCA guidelines through, for instance, the creation of default values. So that's one of the requirements for LCA guidelines, to define well-to-tank default emission factors. And for instance, we did this job for LNG, so an example of fuel for marine sector, through different production pathways. So LNG fossil, e-LNG, so through renewable electricity, and bio-LNG. And we submitted all these default values to the IMO. That is actually, at the moment, it's currently explored and analyzed by the IMO to be included in the future version of the LCA guidelines. Next slide, please. And finally, I'd like to have a word on liquefaction and the gas grid. One of the obstacles we faced through the certification for marine fuels is the possibility to use the gas grid of the different countries, and also about the interface between LNG and gaseous methane. And basically, this is the analysis that's been done by the different certification schemes and what is allowed at the moment. So basically, the traceability of the sustainable properties can go through gas grid, but at the moment it's only for EU gas grid, since for the European framework only, EU has the control of the European gas grid. So they can ensure the countries to set up high quality standards for traceability, for mass balance, etc. That way, it allows to keep the sustainable properties between the feedstock production and biomethane production across a country, transporting this fuel, this methane, through the gas grid and delivering this fuel through a gas terminal. That's possible. Then, what if the terminal is supplying LNG to fuels while the production was methane at gaseous state? In that case, the schemes allow virtual liquefaction to happen. It means that for the final GHG emission calculation for the fuel, the final supplier has to include in the GHG calculation the virtual liquefaction, as if the fuel had been liquefied. And that way, we add the equivalent of the energy consumption, for instance, that ensures that every single step of the supply chain was validated. So thanks to that, in Europe, we are able quite to ease the production of LNG and the qualification of sustainable fuels in the marine sector, thanks to this gas grid traceability in Europe, and thanks to this virtual liquefaction. The question that is ongoing is that what will be the opinion of the IMO on this subject, because today it's clear for the European regulation through the RED, but it's not yet defined for the IMO. And now I will hand over back to Nicolas to talk about the marine fuel market.
Thank you, Victor. Thank you for this very interesting insight on the sustainability framework. So we have set the base here on the maritime decarbonization regulations and the fuel sustainability framework. As you have probably understood, the maritime sustainable fuel market is driven by these regulations. So let's explore their impact on the market. I will only talk about biodiesel here, as it is the main sustainable fuel used by shipping currently, and I won't have enough time to go through all of them. However, feel free to contact us if you want to know more about other sustainable fuels. So this graph is representing the cost of 1 ton of VLSFO equivalent of a blend of VLSFO and biodiesel, FAME. The horizontal axis is providing the blending ratio, so from 0% biofuel on the left to 100% biofuel on the right. The dark blue is the fuel cost of the blend, which increases when you increase the share of bio, which is logic. Purple-ish is the fuel EU penalty, and green is the EU ETS cost. So that's an example for fuel cost on the EU regulations. You see that there is a cost optimum. Here it's around 20% of biofuel, and this graph is done for 2035. The further we move forward in time, the higher the optimal blending ratio gets, and you probably guessed that. We could have done exactly the same for the IMO net zero framework. So knowing this, we can plot the optimal blending ratio for every year. It is the graph on the right with the cost of 1 ton of VLSFO equivalent of the same blend of VLSFO and FAME under the same EU regulations. So in dark blue, you have the fuel cost, and in green, the ETS, and fuel EU is also there, even if we are not paying the penalty. The dashed line represents the blending ratio with the axis on the right. So you see that fuel plus regulation cost is increasing by over 60% by 2035 within EU regulation. So that's the example within EU regulation for one type of fuel. Let's take a step back. This approach can allow us to estimate the volume of sustainable fuel needed under EU regulations. So currently, about 27 million tons of oil equivalent of fuels are concerned by fuel EU. In 2035, 17% will need to be sustainable. Internationally, more than 200 million tons of oil equivalent will be covered by the net zero framework if it is adopted. And 30% would need to be sustainable in 2035, requiring about 70 million tons of oil equivalent of sustainable fuels. These volumes illustrate the exposition of the shipping market to sustainable fuel availability and price. So let's first explore availability. The overall bio and renewable diesel production represents 75 million tons, meaning about 20% of shipping fuel consumption. So here I'm considering only FAME and HVO, not ethanol. Production has been steadily growing at around 6.5% a year. For the coming decade, the growth of around 12% is expected, mostly coming from US, Indonesia, and Brazil. EU is a major producer, but it is importing 15 to 20% of its biodiesel and exporting only 5 to 10%. So as I mentioned, all these numbers contain only FAME and HVO, and you see on the graph at the bottom left that they represent less than half of all the biofuels produced. If you move to the demand side, shipping is a minor player with less than 2% of liquid biofuel demand, as it can be seen on the left graph, which is excluding ethanol, so very minor player, even for FAME and HVO. Road is by far leading the demand. EU is the second largest market for FAME and HVO, with about 23% of demand just behind the US. Transport fuel demand is expected to peak around 2030 because of road transport electrification, which will decrease or stop the increase of the demand on diesel and therefore decrease the demand in biodiesel. It can be seen on the right that after 2030, most of the growth of the demand will come from aviation first and in lesser extent from shipping. If we look more closely at the feedstock availability, shipping and aviation will represent about 75% of the demand growth, with the demand driven by regulations such as CORSIA, ReFuelEU for aviation, and FuelEU Maritime for shipping, which both encourage the use of second-generation biofuels. On the graph on the right, you have the demand as a share of the global supply of feedstocks. In green, it is for first-generation biofuel, and in dark blue for second-generation biofuels. In 2030, second-generation biofuels demand will represent nearly 80% of the available supply. This will most likely lead to a feedstock crunch, an issue in availability. So we can wonder what would be the impact on price of this feedstock crunch. But let's look at the current situation. Biofuels premium stands between 100% and 150% of the LSFO price. Biodiesel price remains very volatile and dependent on regulatory political decisions. You can see on graph the steep variation in fuel prices. The current transposition of RED III that Victor mentioned earlier by member states will intensify the price variations. If we try to make a bit of forecasting, the feedstock cost represents 65 to 80% of the final product cost. This part of the cost is unlikely to decrease, on the contrary to OPEX and CAPEX costs, which should decrease with increased volumes. IMO, in a recent forecast, foresees a slow increase in biofuel prices. Current short-term forecasts see a steeper price increase with a probable supply shortage around 2030 that we mentioned earlier. We have focused this webinar on sustainability, but I would like just to briefly talk about quality requirements. With the evolution of the ISO 8217, FAME and HVO can now be used on board marine engines in up to 100% blending ratio. However, some feedstock will require further verifications, such as cashew nutshell liquid, for example, CNSL. We have a dedicated team inside BV supporting this verification, which can happen for any type of fuel or actually any type of feedstock as well for biofuels. I said I was only going to talk about biodiesel, but I would like to briefly mention LNG and biomethane. Currently, LNG is the main alternative fuel for shipping. Sorry. Biomethane production has been multiplied by more than 6 during the past decade, with Europe and US accounting for 80% of the growth. IEA estimates that nearly 1,000 billion cubic meter equivalent of biogases could be produced sustainably, each year using readily available feedstock, That's about twice current LNG volume. EU has set very ambitious production targets backed by a comprehensive set of regulations. And biomethane has the lowest abatement costs among all alternative fuels. However, demand and therefore prices have increased rapidly and keep doing so. If you want to know more about biomethane or, as I mentioned, any other sustainable fuels, feel free to contact us. Before closing this section, I would like to talk about RED III. We talked about it earlier. It is the third version of the Renewable Energy Directive, adopted by the EU in 2023, and it is a directive, meaning that each member state is free to transpose it the way it wants in its own laws. Member states are currently transposing the directive into their national law. And the RED sets an objective of decarbonization for the transport sector. Victor explained it earlier, and it's now including maritime and aviation. This is why some member states are including maritime in their own regulations. These regulations set mandates of decarbonization or share of renewable energy to fuel suppliers for each transport sector. However, each member state is defining a different regulation, leading to a complex regulatory patchwork. We could do a webinar itself on this transposition, so I will just talk briefly about the ARA region, otherwise it would take far too much time. In the ARA region, Germany has excluded maritime from its regulation, removing any constraint to fuel suppliers for maritime. Netherlands has included maritime with a very ambitious GHG intensity reduction objective and excluded Annex 9B feedstocks, meaning used cooking oil, which is the main feedstock used by shipping currently. Belgium has defined a less ambitious mandate in share of renewable energy, so not on GHG intensity like Netherlands. And it only sets limitation in Annex 9B feedstock, not exclusion. So this patchwork of regulation is still evolving, as not all member states have fully adopted their transposition of the RED III. Let's move to some of the support BV can provide to the market. Sustainable marine fuel is an emerging market, which will have to generate steep growth to fulfill the demand. Many producers are planning new production projects, looking for off-takers and funds from banks and institutions. For example, EU, in its Sustainable Transport Investment Plan, is planning to invest 300 million in the coming 2 years into this market. Trust is needed between players of this new market to ensure investment are directed toward regulatory compliant, technically mature, and cost-competitive projects. Indeed, producers have to deal with uncertain investments and regulation, volatile price and demand, while end users such as shipowners face the rollout of incentive regulation, uncertainty in availability and price of fuel, and the regulatory constraints. Both sides of the marine fuel market needs to be connected to answer their respective needs. However, producers need to understand the market and prove the long-term viability of their project to gain trust from shipowners and investors for offtake and funding. In the meantime, shipowners need to assess their need of sustainable fuels, build a procurement strategy, and secure long-term procurement. Through all this process, BV can support through multiple services, which I will let Victor present you.
Thank you, Nicolas. So, as Bureau Veritas is defined many different sections, like marine and offshore, and like industry, our offer to support you through your sustainable fuel strategy can be done through different aspects. So first, in order to define your fuel strategy and to know what to do, you have to understand what you have to do. And in order to understand the different regulations, we offer trainings through the international regulation or through the EU regulations to better understand the criteria, the objectives, and the consequences on your specific supply chain or your situation. We also can analyze, for an example of fuel production, the compliance with the European regulation or the IMO regulation through like a compliance check for every single criteria that I presented earlier, whether your food production is about to be compliant or not. We also can only focus on the GHG calculation, as a carbon intensity calculation of a fuel is required by most, if not all, the regulations. It's important to have something that is precise, accurate, and relevant. We also can do an impact assessment for instance, the consequences of a fuel regulation on a ship, on a fleet, and what would be the expected changes. We can do a map and a forecast of fuel supply in order to define what is available at which cost. And we can finally help you and support you defining your complete fuel strategy. So first, analyzing your current fleet and the consequences of the current regulations. What would be the possible alternative for fuels? What are the availability? What are the costs of different fuel strategies from which producer? And of course, to optimize your strategy, to define a roadmap, to define some scenarios of supply to ensure that you meet your objectives. We can also do all of these things together through a due diligence to help you from the beginning to the end to define your fuel strategy. Now, I think we will talk about some references that we have, that we worked in the past with Nicolas.
Thank you, Victor. So, a couple of references on my side. Last year, a ship owner of LNG carriers came to us to assess the impact of sustainability regulations from EU and IMO and explore the potential of bio and e-LNG for its operation. We provided a base case of the impact of these regulations on its fleet and an in-depth review of current and future availability and costs for the concerned fuel in the relevant bunkering locations. Based on these two analyses, we were able to run multiple scenarios for its fleet, exploring impact of various uncertainties in order to define the best strategy for its fuel procurement, minimizing cost and reducing risk. We also looked at the chain of custody. Victor mentioned it. There is a complexity with bio and e-LNG in the chain of custody to make sure that the plan was realistic and compliant with regulations. Another example with bio-LNG. I was saying bio-LNG is a very promising fuel for shipping. Well, we get a few demand around bio-LNG. Here in this project that we just finished a few months ago, a ship owner requested a producer to come to us to do a technical due diligence of bio-LNG production project in Malaysia. We provided a thorough analysis of the technical and regulatory viability of the project, regrouping BV capabilities on business sustainability, food and agriculture, biogas and biomethane production, LNG terminals, shipping fuel sustainability regulation at EU and IMO level, and so on and so forth. I only talk about bio-LNG here, but we have many more examples with other types of sustainable fuels. I think, Victor, you had a very interesting project with blue methanol, don't you?
Yes, exactly. So last year, we support a fuel producer that had an innovative process to produce blue methanol. So blue fuels are fuels that use fossil fuel at first, but with carbon capture units. So in that case, he was indeed using a fossil fuel in South Africa. However, thanks to a carbon capture and storage assets, it can be compliant with some regulations through the blue category of fuel. So in that case, this producer wanted to know if its fuel was compliant or not with the different regulation. especially the red one, so the European regulation. So we did like a pre-certification, a compliance check, as I presented, to analyze for every single criteria of the reds if the fuel production process was compliant or not. So we we calculate the carbon intensity through the good methodology. We analyzed the different other inputs as low carbon fuels, as renewable fuels, and to define in which conditions this e-methanol could be compliant. So that's another example of a fuel producer that we have supported. In the next slide, Nicolas, you will see a lot of companies that we have worked with. So it can be fuel producers, fuel consumers, ship owners, etc. And now we are done with the presentation. So we would like to take some time to address some of your questions. So here, while we are answering some of the questions, please feel free to note our points of contact for any additional questions or meeting requests. So either Nicolas and myself. So you can see our mail address. That is the best way to contact us. So we have 13 minutes left. If we can have the time to address some questions. As the conversation section is not available, please use the Q&A section to raise your question. So Nicolas, do you want to start with one of the questions for you?
Yeah, sure. We already have some questions, so I will try to answer one, and I will let you carry on, Victor, with the others. So we have some, I think, interesting questions on the impact of the net zero framework on the EU regulations. I think that's a very good point. The EU regulations are providing quite certainty because they are defined until 2050 and they are stable, or they were stable until now. However, there is a clause in the EU regulations and FuelEU to change it or remove it if the IMO adopts a scheme which is efficient enough in the opinion of EU. So EU has indeed planned to review FuelEU once the net zero framework is adopted, which is not the case yet, and the fact that we are uncertain if it's going to be adopted makes that it is uncertain that the EU will review the FuelEU, and we don't know what's going to happen with FuelEU. So this uncertainty at IMO level is definitely impacting EU, which is not necessarily good news for the market. Victor, if you have got one.
Yes, I can answer to a couple of questions. So first, a question from Joy. Will you be sharing the slides after the session? Yes, of course we will do. Another question from Andrea. Are there financial tools like schemes or funds to promote the uptake of biofuel and limit the commercial impacts on ship owners? So the answer is quite complex. We have seen, for instance, some ports that allow fee reduction for ships that use sustainable fuels. For instance, the port of Rotterdam. So you can get some financial advantages by using alternative fuels. But basically in Europe, the main incentive, the main factor that should drive you to use alternative fuels, unfortunately, is the penalties that you avoid by using them. So that's the objective of the regulations and the RED and the FuelEU Maritime text, etc., is to kind of oblige, to force every actors to comply with this new sustainable context, to make sure they are as low carbon as possible. So yes, at first, of course, it will be maybe more expensive, but it will be the same for everyone to comply with the regulations, unless you will have penalties through the EU ETS as well, through the FuelEU Maritime. But what we hope is that through the developments of these new supply chains with biofuels, with e-fuels, we finally reach kind of scaling or better competition to reduce the cost and the price, so that will limit the costs for the ship owners and at the end the cost to the final user and customers. Another question that I saw is for RED 3 compliance, had you checked with ICC Plus methodology? So ICC Plus is a similar scheme as ICC EU. It just applies also for circular economy, for food and waste, and plastic packages. But basically, the methodology for the GHG calculation and the sustainability requirements are completely aligned with the ISCC EU scheme, which is the red, one of the approved red certification schemes. So basically, if you are if your objective is to be compliant with red, you have to be certified not by ICC Plus, because ICC Plus is not an approved schemes, one of the approved scheme of the red, but by ICC EU or another one like 2BS, like Shore, RedCert, etc. But yes, the methodologies are quite similar. So that's it for the three questions I saw. Nicolas,
Yeah,
if you saw another one.
I have a couple more on my side that I can answer. So there is a question about the impact of RED 3, especially around Netherlands. So I try to answer briefly in the presentation. I can maybe go slightly deeper in the Q&A. I mentioned that Belgium and Holland have both set very ambitious targets, which will generate an important offer for sustainable fuels, but may also increase bunkering prices. Like Rotterdam has become the main biofuel bunkering hub thanks to the HB system, which allowed to generate tickets in the maritime sector that could be sold to road sector. This won't be feasible anymore, so this optimization of cost won't happen, and therefore price are likely to increase, and they already have. Germany, on the other hand, has excluded maritime from its system, meaning that the impact will be very limited, but it also means that sustainable fuel might be more difficult to access for maritime because they will be directed to road transport mostly. I think that you have an example which is quite interesting is Spain. In Spain, it's like it used to be in Netherlands. That's their plan. It's not adopted yet. So their plan is to be able to generate tickets when you sell maritime fuel to the maritime industry, to international maritime sector. And this ticket you will be able to transfer them to the road sector. So you will be able to reduce the cost of maritime bunkering. So that's probably a solution that will decrease the price of sustainable fuel in Spain. But let's be clear that, for example, Netherlands, they have a clause in their regulation, and it is an adopted regulation in Netherlands. The clause is that if the other country around Netherlands are not aligned with Netherlands, which is going to be the case, they have the opportunity to change their own regulation. So it's also likely that Netherlands will make some modification to its regulation. And I have seen questions also around pooling optimization opportunities. So we are seeing quite interesting action with FuelEU and the pooling solution. So on the FuelEU, you can generate a kind of surplus unit. It's not called like that, but that's what it is. And this over compliance, you can trade it with other ship owners which are under compliant. I mentioned that, for example, biomethane has the lowest abatement costs, so it's very efficient to generate surplus unit by using biomethane. And we see ship owners that are using now nearly only biomethane just to generate surplus units. They are selling to other ship owners. So pooling is definitely a very interesting opportunity, but let's be careful. It is a great opportunity now. It will you will still need sustainable fuel in the future, because in 2030 and even more in 2035, when the GHG intensity of FuelEU reference line decrease, all ships will need to use a certain amount of sustainable fuel. It will be very difficult to rely only on the pooling system to be compliant. That's it on the question I have seen.
Okay, just
Yeah.
I will answer to a last one, which is really quick, on the possibility with biogenic CO2 to produce e-methanol or biomethanol. Yes, the pathway to use RFNBO, H2, and biogenic CO2 is the main way to produce e-methanol. Even with biogenic CO, we can produce a mixture between e-methanol and biomethanol that is completely included in the EU regulations in the red through the delegated acts of 2023, especially. And for the internal maritime regulation, it's still ongoing, so we have to have proof of that. But for now, we already know that it's well applied on the European regulation. Now it's time to conclude this webinar. So Laurence, if you want to have a last word.
Yes, but the last word will be a big thank you. Thank you to our speakers, and thank you to all of you attending this session. We really hope that it has been providing interesting insights to you. And of course, we are very happy to continue and stay in touch with you. You are the contact person to go to. After this session, you will receive an email with the slides, as well as the key takeaways from this session, and a recording that we can share, of course, with those who have not been able to attend. So thank you very much, and having a good follow of the day. Thank you. Bye.
Thank you. Bye-bye.